Hey, what's up guys? Welcome back to Josh Does Coding. In today's video, we're going to continue on with our Advanced AI series, and we're going to be going over services and aborts in behavior trees to make it so that our AI smoothly chases the player as the player's location updates, and also so it smoothly transitions from patrolling to chasing instead of waiting the 2 to 4 seconds that we currently have it waiting in the behavior tree. So let's get started by actually opening up our behavior tree. And you can see right now, the wait I'm talking about is this 2 to 4 seconds right here. Essentially, while the AI is patrolling, it's going to spot the player, but it's still going to finish out this logic, which includes waiting 2 to 4 seconds, which can make it feel very janky and unnatural. So what we want to do, if we click on our Blackboard-based condition here, that decorator we added the other day, what we want to do is we want to come to Observer Aborts. We want to click on Self. Now, just a brief explanation of what this does is this will, if we hit Self, you can actually see it's going to abort everything that this sequence calls, including itself. Where if you do lower priority, it's going to call anything that's lower priority. So remember, priorities from left to right. So you can see this will get canceled. Or you can do both and everything will get canceled. Now for our case, we just want to do self because we only want our patrol to stop when the player gets spotted. Now in Notify Observer, you can choose to abort the observer when the result changes or when the value changes. Now since we're using a Boolean, both of these will work because if it was false and the value changes, it's now true. And then if it changes again, it will be false again. But we're just going to leave it on result change because that would be the proper thing to do here. So now when the player gets spotted, this logic is going to instantly stop. And we can actually see this in work right away. So when we come and play, you can see it's instantly coming towards us when it spotted us, unlike last time. So again, it's patrolling. It doesn't see us. As soon as we move into its sight, it's going to come chasing us. It's not going to wait that 2 to 4 seconds. Once again, just as demonstration, it's patrolling. Doesn't see us. Now it sees us, it comes running on over to us. Does not wait that 2 to 4 seconds. But we still have that issue we brought up the other day, which we just saw there, of that it doesn't actively update the player's location. It is when we call chase, it gets the location and then moves to that location, but this target location doesn't update as it's chasing the player. So like we just saw there, it chased the player. When it saw it, it chased the player to the left and then going up instead of chasing the player diagonally. So the way we can fix this is by using something called a service. So if you right click on our chase sequence and we go to the very bottom, you can see add service. Currently, you'll have default focus and run EQS. I just have this one here from before. Sorry about that. So again, if we come to our chase sequence and we add a service, you'll see a default focus and run EQS. So we're going to want to make our own sequence or our own service that will update the chase target location every X seconds. So to do that, we can come up to the top here and hit new service, and then we'll just click BT service blueprint base. So this is the parent class. We can then choose where we want to add this. So I'll create a new folder and I'll call it services. I will open up that service folder and I will call this BT service get chase target location. Now, if you're following along from last video, you'll know we have this task that we created, get chase location. Well, what we're going to do is essentially turn this into a service. So, in here, we have this Blackboard value that's getting set. And we are going to do the exact same thing over in our BT service, get chase target location. Now, you can copy and paste this, but for the sake of the tutorial and for anyone who's just watching along, I will go ahead and add it from scratch here. So in our BT service, we want to get events receive tick AI. And what we're going to do is get player character. We're going to get actor location. And then once again, we need to create a variable, and we'll call this chase target location. And again, it is not of type vector. It is of type Blackboard key selector. Then we drag this into our graph. We go ahead and set value as vector. And we're going to pass in this get actor location. And as always, make sure you click this little eye here so that it is visible in the behavior tree. All right. So now when we come back to our behavior tree, if we select our chase sequence, we can now add service, and you can see our BT service get chase target location. When you click that, you'll get this nice little green box below your sequence. And the first thing we need to do is set our chase target location to the chase target location key from our Blackboard. We then want to specify how often this service should get called. So right now it's getting called every 0.5 seconds with a random deviation of 0.1. So every 0.4 to 0.6 seconds. Now we don't want a deviation for this, so I'm going to set that to 0. And I'm also going to set this interval to 0.1. Now, we aren't doing very complex logic in here, so we can do this very often unless you have, hundreds of AI in your game, then maybe you want to increase this interval a bit. But for today's tutorial, we're going to put at 0.1. So, we are now updating this chase target location every 0.1 seconds. What does that mean? Well, right off the bat, we can get rid of this get chase location. That task we made, no longer needed, so we can just delete it from our behavior tree. Matter of fact, we can actually go a step further, and we can just completely delete the task. Perfect. So we just converted our task into our first ever service. And you can already see why this is better. Instead of doing it once every time the AI moves to it, we're now doing it every 0.1 seconds. So, similar to what we did over on here, we're also going to want to add in an abort to our chase. So select your has spotted player over top of the chase, observer reports, and we're going to set it to self. So if the AI loses sight of the player, it's going to stop chasing the player and go back to patrolling. Now this abort is optional. If you lose sight of the player and you want your AI to continue going to the last known location of the player, you do not need to abort this. But if you wanted to abort as soon as the AI loses sight of the player, you can put observer aborts to self, which I will do here just so I can show it off. So the last thing we need to do now is update this move to location node. So the issue with this move to location node is that right now it is not going to be getting updated because it itself is not being aborted. Now, there is a few ways we can handle this, but the way I'm going to do it is we're actually going to create our own task instead of using this move to. So what we're going to do is we're going to come to our content browser, come to our tasks. We're going to create a new blueprint class, and it will be of BTT task blueprint base, and we'll call this BTT underscore chase player. All right, once we're in here, we're going to do event receive execute AI. We're going to drag out and we're going to say AI move to. We're going to pass our controlled pawn into this pawn variable. And then we need a destination. So we can create a variable and we'll call it chase target location. We'll make it not of type vector, but of type Blackboard key selector. We'll hit this I so that it is a public variable and editable. Now we've always set a Blackboard key location or value, but this time we're going to get a Blackboard value as a vector, and we're going to pass it into this destination. So this code right here will tell our AI to move to our target location. But we don't want to just do this once. We want to do this every X seconds. We want to make sure that this destination is getting updated. So what we can do is we can drag out from our event receive execute, and we can add a timer. It'll be set timer by event. Then we can just copy this AI move to code. We can just cut this, Control X, and we'll paste it down here. From this event, in the set timer by event, we're going to drag out and add custom events. We'll call this move to target location. We'll hook this up to our AI move to. And then up here in the set timer by events, we can set how often we want this to happen. Now I'm going to set this to 0.1. And we'll make sure that it is looping. So while this task is being executed every 0.1 seconds, we're going to tell our AI to move to this chase target location. Now, as a note, this time does not need to match this time. This can be done every 0.5 seconds, and this can be done every 0.1 seconds, because even though this gets called every 0.1 seconds, it will only actually change something if the chase target location was updated from the service. Because after 0.1 seconds, if this hasn't been updated, it's just going to say to keep moving to the same location. So we don't have to worry about keeping those values the same, though I have made them the same. Now we're once again going to need to hook up our controlled pawn to this pawn variable just because we cut this node. And then you can set your acceptance radius, which is once again how close the AI needs to get to the location before it's considered completed. Now for outputs, we have 3. This top one, this will get called while this AI move to is being done. So it gets called immediately after we tell our AI to move to this location. On success gets called once our AI reaches its location. And on failed gets called if our AI fails to reach its location. So on success, we're going to drag out and we're going to finish execute. Oops. We're going to finish execute and we'll say it was a success. On fail, we will finish execute and say that it failed. All right, we can now compile and save this. And if we come back to our behavior tree, we can get rid of this old move to, and we will now add in our BTT chase player. In the chase target location, we can pass in the chase target location Blackboard key we have. And now when we save this and we go run our game, you can see the AI spotted us, it chased us. And now when we update our location, it actively turns and follows us. It doesn't wait to reach the old location. It's going to actively update its location and chase the player. And when the AI loses sight of the player, it's going to immediately go back to patrolling because of that other abort we set up on the chase sequence here. Then, once again, of course, if it sees us again, it's going to instantly start chasing the player. Once again, properly updating the player location and actively chasing it across the map. All right. If you guys did enjoy this video, be sure to leave a like. And if you want to keep up with the series, be sure to subscribe so you don't miss the next video. Be sure to leave any comments down below if you have any questions or any suggestions on how I can improve these videos. And with that said, I hope you guys have a good rest of your day and good luck with your games.